Welcome, my friends. In this video, I will be solving a variety of trigonometric equations. Our first question asks us to find all solutions to 2 cosine theta plus 1 is equal to 0 on the interval of 0 to 2 pi, including the 0 but not the 2 pi. So this is basically just one revolution of the circle. Okay, so our first step is going to be to subtract 1 from both sides of the equation. So if we subtract 1, we'll have 2 times the cosine of theta is equal to negative 1. And then we can divide both sides by 2. We will get that cosine of theta is equal to negative 1/2. And our goal is to solve for theta. So think about this. Cosine of what angle will give you negative 1/2 on the interval of 0 to 2 pi? If you think of cosine as the x-coordinate on the unit circle, there are 2 times when the x-coordinate is at negative 1/2. Once in quadrant 2 and another time in quadrant 3. For quadrant 2, hopefully you know that that is 2 pi over 3. Cosine of 2 pi over 3 is negative 1/2. And then there's going to be another case in quadrant 3. Cosine is also negative there, and that is going to be 4 pi over 3. So cosine of 4 pi over 3 or 2 pi over 3, those will both be negative 1/2. And those are the only times when cosine of an angle is negative 1/2 on the interval of 0 to 2 pi. So we are done. All right, let's try another problem. We are asked to find all solutions to 3 tangent theta minus square root 3 is equal to 0 in the interval of 0 to 2 pi. So we have 3 tangent theta minus the square root of 3 is equal to 0. We want to solve for tangent of theta, so we will want to isolate that on one side of the equation. So let's add the square root of 3 to both sides. We will get 3 tangent theta is equal to the square root of 3. Divide both sides by 3, and we will get tangent of theta is equal to the square root of 3 over 3. Now, hopefully you know your unit circle for tangent, and know that tangent of pi over 6 is equal to the square root of 3 over 3. Okay, so that is one of the angles on 0 to 2 pi that gives us square root 3 over 3. But there's going to be one more angle. And how do we find that angle? Well, the way I think about it is tangent has a period of pi. So if we just add pi to any angle, we will find another angle that has the same output. So let's add pi to this, and we will get 7 pi over 6. So maybe think of it as adding 6 pi over 6. We will get 7 pi over 6. This is another angle that if we take the tangent of, we will get square root 3 over 3. So these are our 2 answers. Let's try another problem. We are asked to find all solutions to square root 3 cosecant of theta plus 2 is equal to 0, again on one revolution of the circle. So our first step will be to subtract 2 from both sides of the equation. We will get square root 3 cosecant of theta is equal to negative 2. Let's divide both sides by the square root of 3. We will get cosecant of theta is equal to negative 2 over the square root of 3. Now it's a little bit easier to think about sine, so instead of using cosecant, we can use the reciprocal function of sine. This will be that sine of theta is equal to the reciprocal of this, which would be negative square root 3 over 2. So we got to ask ourselves, sine of what angle is equal to negative square root 3 over 2 on the interval of 0 to 2 pi? Well, sine is negative in quadrants 3 and 4. So we'll need one angle in quadrant 3 and another angle in quadrant 4. We know that sine of pi over 3 is equal to the square root of 3 over 2. So pi over 3 is our reference angle. So that means that the 2 solutions will be 4 pi over 3 in quadrant 3, and then also 5 pi over 3 in quadrant 4. These are our 2 answers. Okay, let's try a few problems where the angle is not a commonly known angle on the unit circle. So we are asked to find solutions to cosine of theta is equal to 0.4671 on the interval of one revolution of the circle. Okay, so you may remember to solve for theta when it's not a commonly known angle, you can use the inverse function. So if we use inverse cosine, that will give us one of the 2 answers on one revolution of the circle. Okay, and that's going to give us, if we type that into our calculator and we're in radians, about 1.08 radians. Okay. So what is this actually giving us? Maybe it's helpful to draw a picture and kind of have our circle go in here. So if we're thinking about a unit circle, we could think of this cosine of theta as the x-coordinate on the unit circle. So we could have some point on the unit circle at about 0.4671 in terms of x. And there would be some angle that would create that point, right? And that angle is 1.08 radians, okay? Might seem kind of weird because typically we think of radians as in terms of pi, but oftentimes we can't really express it in terms of pi if we don't have a commonly known angle, okay? There are 2 different places on the unit circle where the x-coordinate is 0.4671. There's one right here, and there's going to be another one down here in quadrant 4, specifically right down here, right? So there's going to be another angle. This is going to be the angle swept all the way out here, so it's going to be a large angle, such that cosine of that angle will be 0.4671. Okay, and what is that angle going to be? Well, we have to kind of think a little bit critically about this. I would think of the entire revolution of the circle as being 2 pi. So all the way around is 2 pi. And we're a little bit less than that, right? So we're a little bit less than 2 pi. How much less are we? We are 1.08 radians less than 2 pi to get this angle here all the way around, right? So if we take 2 pi all the way around and subtract the amount that we are over, 1.08, we will find this little blue angle here, that cosine of which that angle is 0.4671, okay? So if we take 2 pi and subtract 1.08, we get, if you plug that into your calculator, about 5.20, okay? So the second angle is 5.20 radians. Cosine of 1.08 or 5.2 will give you 0.4671. All right, let's try another example. We are asked to find all solutions to cotangent of theta is equal to -3/2 in the interval of 0 to 2 pi. Okay, so rather than thinking about cotangent, maybe I would prefer to think about tangent. Tangent is the reciprocal of cotangent. So if cotangent of theta is equal to -3/2, that means tangent of theta must be -2/3. We can take the inverse tangent of both sides. We will get that theta is equal to the inverse tangent of -2/3. If we plug that into our calculator, and our calculator is in radians, we will get that theta is equal to -0.588 radians. So let's think about where that is on a unit circle. -0.588 radians, that's a negative angle, so we will be sweeping out clockwise. So it's going to be something right around here. Okay, so the angle of theta equals -0.588 radians would give us a y to x ratio of -2/3, or tangent of that angle would give us -2/3. Okay, but this angle is not one of our answers because we need angles between 0 and 2 pi. So if we want to find the other kind of corresponding angle to this that's coterminal, we can just add 2 pi. If we add 2 pi to this, we will get another angle that's going to be positive. So that would be the angle from the positive x-axis all the way around, which is going to be between 0 and 2 pi. So let's add 2 pi to that, and we will get about 5.7. So this angle is 5.7, coterminal with -0.588. So tangent of 5.7 is going to give us -2/3. Okay, then there's going to be one more angle, and that's going to be somewhere over here, right? So tangent is negative over here. We have a negative value for tangent. Tangent is negative in quadrant 4, but also it's going to be negative in quadrant 2 because sine and cosine have opposite signs. So here's what that other angle would look like, and that would be the angle all the way around here. So you can really find this in a number of different ways. I could take the 5.7 radians and subtract pi. I could take my original value here and add pi. Let's see what I did here. It looks like I took 5.7 and I subtracted pi. So whichever way you want to get to this other angle, it's just going to be either subtracting pi from 5.7 or adding pi to -0.588. Either way, you should get 2.56. Okay, so our two answers are 5.7 and 2.56. Let's try a problem that's a little bit different. We are asked to find all solutions to cosine of theta is equal to the square root of 3/2. Notice in this problem, we are not restricted to the interval of 0 to 2 pi. We are asked to find all solutions. Remember that the trig functions are cyclical, so they just repeat themselves over and over and over. In the case of cosine, every 2 pi radians. So there's really going to be an infinite number of possible solutions. And I'll show you how to represent that here in a moment. But first of all, let's just find the times when cosine is equal to square root of 3/2 on one revolution of the circle. So here I have my unit circle. And if you look at pi over 6, you will see that the x coordinate is square root 3/2. So that's going to be one of our answers. And the other time is going to be down here at 11 pi over 6. We also have an x coordinate of square root 3/2. Okay, but we're not limited to just those solutions. We could go many times around the circle. So if we added 2 pi to either of these, we would be at a coterminal angle that gives us the same output for cosine. Okay, so if you added 2 pi to pi over 6, you would be at, well, I guess you'd be adding 12 pi over 6, you'd be at 13 pi over 6. That would be another solution. You could do the same thing for 11 pi over 6. Or you could subtract 2 pi, or you could add 4 pi or 6 pi, so that you could really add any multiple of 2 pi. And the way that we represent this is we say that we add 2k pi to each of our results. Okay, so that basically is saying add any multiple of 2 pi to our result. Okay? And we also want to specify that k is going to be an integer. And the way we do that is by saying that k is an integer. The z stands for an integer, meaning just a whole number, could be either positive or negative. So things like 0, 1, 2, 3, 4, or -1, -2, -3, -4. So really pi over 6 plus 2 pi times any integer, or 11 pi over 6 plus 2 pi times any integer. So we can just add or subtract 2 pi as many times as we want to get coterminal angles, that cosine of which will still give us the square root of 3 over 2. So these are our final answers for this problem. Let's try one final problem. We are asked to find all solutions to square root 3 tangent of theta minus 1 is equal to 0. So let's start off by adding 1 to both sides of the equation. We will get square root of 3 tangent of theta is equal to 1. Let's divide both sides by the square root of 3, and we will get tangent of theta is equal to 1 over the square root of 3. This might not look like a common value for tangent, but if we rationalize the denominator by multiplying by the square root of 3 over itself, we will get that tangent of theta is equal to the square root of 3 over 3. Now this should look like a familiar value for tangent. This is pi over 6. Tangent of pi over 6 is equal to square root of 3 over 3. If you're unsure, take the y-coordinate at pi over 6 and divide by the x-coordinate, and you will indeed get the square root of 3 over 3 once you simplify. Now I find the tangent ones to be a little bit easier because I know the period of tangent is pi. So if I'd like to find the other solution on one rotation of the circle, I can just add pi to this, and I would get 7 pi over 6. But again, we have one of these problems where we want to find all solutions, okay? So let's just add pi or subtract pi as many times as we want. So if I add pi once, I'll be at 7 pi over 6. If I add pi again, I'll be at an angle coterminal with pi over 6. Add again, again. So I can add pi as many times as I want, or subtract pi as many times as I want. And in either case, I will get an angle, that tangent of which will give me the square root of 3 over 3. So the way that we represent this is we say plus k times pi, again with k being an integer. All right, my friends, that finishes my video relating to solving trigonometric equations.